Welcome to today's IOMP webinar. I'm John Damilakis. I'm the president of the IOMP, the International Organization for Medical Physics. The title of the webinar is Meet the Industry, Streamlining Radiation Oncology, Automated Planning and QA. Today we'll hear from industry experts. They will share insights into how automated treatment planning and quality assurance tools are transforming clinical workflows. Once again, I would like to thank Magdalena, our Secretary General, who is always behind the scenes to take care of all technical aspects of webinars. And just to remind you that after the presentations, there will be time for your questions. So please use the Q&A feature, Zoom feature, to write your questions. So again, we have two experts from the industry. And without further ado, let's begin with our first speaker, Dr. Mercedes Riveira. The title of her talk is Accelerating Breast Planning, Radformation's Automated Solution for Enhanced Efficiency. I know Mercedes. In my capacity as the Symphonia project, it was a European Horizon project. So in my capacity as the coordinator of that project, I know Mercedes because, she did her MSc and PhD at Complutense University of Madrid, and her doctoral work focused on personalized dosimetry, nuclear medicine, and AI applications in medical imaging. A lot of research work was done within the framework of the Symphonia project, right? So I know Mercedes since the beginning of that project. Now Mercedes works at Radformation, and she also serves as an associate editor for the British Journal of Radiology AI journal. Mercedes, the floor is yours.
Thank you, John. Thank you very much for the presentation. Okay. Can you see my screen?
Yes.
Okay. Perfect. Let me see one moment. All right. Okay, so yes, hello everyone. Thank you very much for your interest in joining this webinar. Thank you, John, for the very nice introduction. I'm very happy to see you again. So today I'd like to introduce you to some of the Radformation's automated solutions that are designed to enhance efficiency in radiotherapy. I will first introduce all of them so that you are familiar, and then I will show how we can use all of them together on a real-life breast cancer patient, which is why this talk is mainly focused on that. For those who don't know Radformation, we're a company that harnesses the power of AI and automation to optimize the radiotherapy workflow so that you can deliver fast, consistent, and also high quality care with ease. And thanks to these innovations, Radformation is currently proudly trusted by over 2,000 clinics worldwide. Here we tackle every step of the radiotherapy workflow and patient's journey, from AI-based contouring with AutoContour, automated 3D plan generation, plan evaluation, and patient-specific QA, treatment evaluation, and of course, machine QA. Well, of course, I'd love to cover all of them, all of these products, but my goal today is to bring you 4 of these products, or in other words, what we call our core 4. Starting with the first step in the treatment process, we have AutoContour to generate our AI-based contour. Not only that, but also edit them, adding plan instructors, registrations, and much more you will see later on. Then we can use EZFluence to automate and speed up our 3D planning, not only for breast, but for all sites. After planning, of course, we want to make sure that the plan is correct and that is meeting our goals. So for that, we will use ClearCheck, our planning verification tool. And as part of this verification process, we will run ClearCalc to perform a completely independent second calculation, which along with Rad Monte Carlo allows for a Monte Carlo-based secondary calculation. So let's start first, as he said, with the contouring. So in the AI contouring front, AutoContour can deliver significant time savings and a significant number of models to the clinicians, about 290 models for CT or MR. As I briefly said before, AutoContour also provides some advanced features, such as the ability to perform planning structures, register images, either with rigid or deformable registrations, deform the contours, and deform the dose as well to perform dose accumulation with plan sums for re-irradiation cases. The latter is in conjunction with ClearCheck, which I will explain later on. On the EZFluence front, so for the planning side, EZFluence similarly provides significant time savings as stated by case studies performed all over the world. But of course, along with the time savings, or even more important than that, is the quality of the plan. And this is because with EZFluence, you can create dosimetrically superior or equal plans compared to manual planning, with, as you see, equal or better coverage, lower hotspots, and also equal or better V105. So in summary, EZFluence is a plugin for Eclipse, Monaco, and RayStation TPSs that will generate optimal fluence maps to produce a consistent and a homogeneous dose distribution for 3D-based photon plans, while of course reducing the time spent in 3D planning, the plan complexity, the inter-person variability, and as mentioned before, minimizing the dose hotspots, all of that automatically. Since these fluence maps can be stratified to have the corresponding fill-in-fill plans, we can use either these with sliding window or fill-in-fill techniques. Regarding the breast planning, we can use it for single or mixed energies, 3-4 fields breast optimizations with superclaves or PAB fields. But of course, this is not only limited for breast planning. It can be used on any electronic compensator or fill-in-fill plan from head to toe, including whole brain, for example, spine, or lung, pelvis, or even extremities for palliative cases. So we're coming now to the verification of our plan. And for that, we're going to use ClearCheck, our plan verification tool. ClearCheck is widely used to enhance the workflow efficiency by minimizing the manual QA task and improving compliance with institutional protocols such as TG275, for example. It has proven to be a tool that provides not only significant time reductions, as stated, for example, by Weill Cornell Medicine, whose average consult to treatment time was reduced by 3 days from 8 to 5 days with ClearCalc. But even most important than the time savings, as with EZFluence, is that users trust ClearCheck to ensure the plan accuracy, to reduce the back and forth between physicists, dosimetrists, and doctors, and all those tedious little manual and visual checks, what of course allows them to focus on the big picture and refine treatment strategies to improve other aspects of the patient's treatment. In summary, in one single click, ClearCheck will provide different types of checks, such as more than 20 different types of patient-specific dose constraints, including the ability to perform EQD2 and BED analysis, ensure the structure's integrity so that there are no stray pixels, for example, perform about 90 different types of physics checks. It allows you to compare as well different plans and perform plan sums, or, for example, virtually check the gantry in relation to the patient or the support structures to make sure that there are no potential collisions. And of course, print all of these into a comprehensive and personalized report. So finally, we reach ClearCalc, our fast and versatile independent second dose calculation tool with support for photons, electrons, brachytherapy, and other specific machines. One of the main advantage, I would say, of ClearCalc is how easy it is to use it and how fast, because in one single click, you have all the information available to print for report. As he said, in one single click, ClearCalc will perform those calculations in case of photons based on a modified finite size pencil beam and compare them against the TPS so that we have modular units comparison, point doses calculation, 3D point dose statistics, log file analysis, and much more. Part of the reason why ClearCalc is so fast and easy is because it includes an automatic point selection tool that eliminates the need to spend time manually looking and choosing for the correct point. Instead, it intelligently identifies a representative passing point in the high dose region of the CT, ensuring that the point is a good evaluation point for all fields, and these even including for the most challenging cases, such as multi-lesion cases. And lastly, integrated into ClearCalc, we have Rad Monte Carlo, which is an advanced Monte Carlo-based dose calculation engine, which is designed to provide a full 3D dose matrix so that we can perform volumetric comparisons. All right, so now that we've, as I said, introduced all these products, let's see them in action. In this case, this breast patient contains 2 tangents, but as I stated before, we could also work with 3 and 4 fields, superclav, or even with dynamic arcs. So let me just change the screen that I am showing. Okay, that's all right. So in this case, I will be using these tools with the Eclipse TPS. But I could be using also, for example, the standalone applications, which is completely usable for any TPS. So let's start, as I said, with this patient by opening AutoContour directly from the tools bar. The first thing when we open AutoContour is that we need to select the template that we want to apply with the specific structures. We can also template all the planning structures that we want to apply, the Boolean operations. And then when we click the OK, we just go straight to the user interface. As you can see, we can toggle between the DRRs or the normal views, for example. I will sort these structures, this list of structures by status, so that the first that are being processed appear on top. So what we want to make sure here with AutoContour is that you carefully review all of these structures that are generated by the AI, by AutoContour. So for that, we offer this automatic scrolling, this auto-scrolling operation, so that the review process is easy. As you can see, the window level, for example, changes according to the structure that I am reviewing at that point. Of course, I can pause it and do it manually if I want, or for example, change the speed at which the contouring is, at which the auto-scrolling is performed. As I said, this is, of course, something that we want you to do to make sure that you know that all the structures are correct. This can be speed up, for example, by doing what we call a joint review. In this case, we are not only reviewing the left lung, but also the right and the trachea, as these are structures that share some characteristics. More things that we can do here on the fly with our structures is to choose or change the model that has been used to generate that structure. We can set those to high resolution or set a Hounsfield unit override value if we want. Something that we can do in order to approve all of these structures at once is just to show them at the same time in my CT and then review from head to toe our whole view, our whole CT. So once all the structures and all the slices have been at least shown once, we can go and do a general approval, or we can approve all of them. This is because we need to do this step in order to send the structures back to our TPS. As you can see, this is also an editing space. So we also have the brush, the pencil, and other functionalities, such as, for example, this keyberry and slice, which will allow us to edit, for example, only the visible slides or export them just like that. As I said before, we also have the planning structures that are Boolean operations that we can template out and perform rigid, deformable, and rigid registration, deformable, and deform the dose. So once I'm finished and I'm happy with these structures, I will just export all of them back to Eclipse. Remember that only the approved structures will be sent back. Okay, so now we have all our structures, and now let's go to the second step. We just need the first dose calculation, our fields, and the open MLCs. So now, as we did with AutoContour from the tools bar, we will launch EZFluence. So at the first point here, just at a glance, EZFluence will provide us with a very good plan already with a very decent coverage, no hotspots, and a very minimum V105. We will be giving these DVH curves that we can normalize according to a maximum dose that we want to all those curves to comply with or a specific coverage. However, normally the first option is the best one. We can turn this view from isodose to color wash and also the DVH to the beam's eye view. Here we can show the fluence, the maximum dose, and we also have this editing tool that we can heat up or cool down the plan by just painting on it. If we are used to working with fluence, we can just export it. Or if we want to generate the fill and fill, we just select the minimum monitor units per segment and the number of segments that we want to generate for the fill and fill. So we have all our subfields here in this view. We can review one by one for both fields in this case. And another editing tool that we can have here is that we can manually modify the banks, both the left or the right leaf. In this case, I'm not happy with these edits, so I will just undo what I've just performed with this arrow or with the fluence snapshot. So if I'm happy with these, again, now with this field and field, I will just click that button and export all of these subfields back to Eclipse. When they reach Eclipse, you will see that they appear here all unmerged. So now I just need to go here and merge all my subfields. This is very important. As you see here, the last dose calculation is performed by Eclipse, so according to your algorithm. All right, so now we have the contour, the planning. So let's go to the two last steps. So let's, with these, go again to our tools and open ClearCheck. All right, so the first thing that we find with ClearCheck is our dose constraints. This is, of course, template out. I'm reading the information from my plan. We have the constraint, the goal, and of course, the results. Everything is color-coded, green for passing, red for not passing, and blue for a conditional value. Both red and blue, we can verify that this is okay and add some comments if we want them to pass. We can see also our DVH. This is quite a dynamic DVH. We can see the dose constraint, the constraint markers that we are showing in the table. And we have also this 3 view that we can use to review, for example, the dose overgrid with our doctor if we want. This is the structures check section. So here we will make sure that our structures are correct. So no stray pixels, no holes, everything's inside the body. And also, for example, the laterality, so that we are treating the left breast and not the right one. For everything that is failing, for example, in this case, we can also have this 3D view that makes us an idea of how that that failure is looking like. And finally, we reach the physics checks section. So in this case, we have about 90 different types of checks. In this case, for example, we forgot to insert the couch. So it's notifying me that I need to put the couch. And also there is this collision checks section that it's included into ClearCheck, as I said before. This will make sure that my patient is not collisioning either my structures or my Hounsfield units. This is also dynamic, so I can change the gantry collimator or couch rotation or also do some translations. So I can use also this as a sandbox to play with my isocenter, for example, with my patient. So once I have make sure that we don't have any collisions, neither with the structures or Hounsfield units, if I don't want, I will just send these results back to ClearCheck. And now, as you will see, my collision checks row is filled and completed. There are some other things that we can perform, such as compare, for example, different plants, open the portal dosimetry or plant sums. But in this case, I will open ClearCalc, which is our, as I said, our secondary calculation tool. In this case, as I'm working with a photon plan, I will see right away our monitor units results. So the TPS and the ClearCalc calculation and the difference, and it's passing or failing according to a user-defined tolerance. Our calculation point doses, as you can see here as well. And if I'm happy with this calculation, I can also see this gamma analysis evaluation. If I'm happy with these, I can just go straight back to ClearCheck and finish my calculation. However, in this case, to show you this Rad Monte Carlo algorithm, I will also go here to the top and run the Monte Carlo results. This normally takes up to 2 minutes, so I just speed these up for the sake of time, but it's indeed very fast. With these Monte Carlo results, we have the full 3D gamma analysis. We can modify the criteria. So for example, reduce the criteria of the gamma analysis to 3.3 in this case, and see that this is still passing. We have this color wash that we can toggle between those color wash or the gamma index pass and fail, for example. And of course, if we continue scrolling, we have the transfer profiles and the DVH. One other interesting thing that we could do with ClearCalc is to perform, for example, log file analysis. So with that log file analysis, we could be comparing the ClearCalc calculation, the TPS, and the ClearCalc calculation of the dose, but from the delivery log files. In this case, I will just go straight away and send these results back to ClearCheck. And why am I sending the results back to ClearCheck? Well, because this will allow me to have a combined report with not only the results from ClearCheck, but also the results from ClearCalc. So as you can see, this is a very good stratified report here in the right. We have all the different sections that we can jump right away if we want to review, for example, only those that are not passing or just with a condition. We have different views, the images of the patient, the plant checks, so of course, everything that we've seen in ClearCheck. And as I briefly said before, also our ClearCalc results. In this case, both for the modified finite size pentacle beam and the Monte Carlo calculation. We can insert some screenshots, PDFs, etc. But the most important part for me in this case, and mostly for ARIA users, is that we can send this report directly to the ARIA documents section of the patient. So just with that, I will finish this video. You will see that now I've already sent this document to the document section of the patient, this report. So now let me open the document section and show you how this report with everything that we've performed here with ClearCheck and ClearCalc is reflected here. All right, so I hope that was clear and insightful. Of course, if you have any questions, I will be happy to take all of them. And I'm very happy for this opportunity. So also, thank you to John and Magdalena again.
Thank you, Mercedes. I hope you can hear me. Can you?
Yes.
I have some connection problems, but I'm happy that you can hear me.
I can hear
at least I can introduce our second speaker, and then I will restart my computer. Thank you again. Our second speaker is Mr. Greg Martin. Hi, Greg. Welcome. Martin is a registered clinical scientist in the United Kingdom. So he has 5 years clinical experience working in I understand, big radiotherapy department center, NHS center with 10 Linux. So they keep you very busy, Greg, I assume.
Yes, I used to be very busy. I have a slightly nicer work-life balance now, I would say.
Okay. So, Greg, uh, the floor is yours. And at the end, once again, I'm happy we have more than 1,100 colleagues attending this important webinar. Greg, the floor is yours. Thank you.
Thanks a lot, John. Thanks for the introduction and good luck with your IT. It's always
Thank
fun
you.
when you're doing these kind of events when our IT decides that that's the perfect moment to misbehave. So my name is Greg. I lead the international application physics team for Sun Nuclear. And I did used to work as a real medical physicist before I moved across to this side, but I had a lot of experience using the Sun Nuclear products clinically, and now I'm lucky enough to get to talk to them to people like yourselves. Speaking to over 1,000 people is an absolute privilege, so I want to thank you all for joining. If there's any questions now or in the future, you can put them in the Q&A, or equally you can reach out to me directly. That's not a problem at all. So my goal today is to talk you through kind of the Sun Nuclear ecosystem, focusing on SunCheck and talking about the connected workspaces that we have within. So first things first. So we all know the challenges that the medical physics community, the radiotherapy community is facing globally, whether that is staffing challenges, increased workloads, budgetary challenges. There is a rapid adoption of new technology, and maintaining pace, updating with all of those is a big challenge for radiotherapy departments. And in this growing world, bigger departments, more patients, the more sources of data we have can also add in an additional challenge. We need to try and have independent QA. It's a real challenge to try and standardize things across each machine, each department, each country. And in order to do more with less people, then you need efficiency. So just kind of introducing and addressing that landscape. So it's Sun, the kind of goal is what we kind of think of as a quality management system solution. So we try and move away from just individual QA tasks or tools to a complete quality management system in the same place. So a single database for all of your results, a single interface with all of your different computer systems, all of your hardware, all of your different patient results, all living through that single interface. All of your data is then centralized and ease of access. You can then interrogate and analyze data from different aspects of your department. If you have a single quality management solution, then you can standardize your workflows much easier. You start to get the benefits of automation. We then highlight opportunities to improve for things where we maybe weren't aware of in the past. We can work from anywhere within our hospital, but also remotely as well with the remote solutions. And it just gives that big picture, right? It gives you that oversight. You can discuss things with your peers and do those comparisons. And equally, the reporting that is now critical around the world in terms of compliance and accreditation can be then easily accessed from that single quality management system. So that is our goal. It's Sun Nuclear. And although we have lots of independent QA tools, we want to kind of try and go beyond that. So we want to talk about comprehensive, independent quality management solutions. So we want that to cover our hardware, so covering things like anatomical phantoms, motion phantoms, through to patient QA hardware, dosimetry, machine QA, and including our software solutions, which is, oh, you can't see my presentation. Someone's just messaged. Let's go back to that. Apologies. Can you see it now? I should have asked that at the start. I'll take that as a yes. Thanks, Mercedes. So let's go through this. So there we go. That's what I'm looking for. So I just kind of try to introduce the landscape, the challenges, and what our kind of goal is. And then now we can start talking about solutions. So independence is at the core of what QA providers, what we want to kind of offer. And, the whole kind of goal of that independent check to your planning systems, to your other kind of primary systems in your department is primarily safety. Just about every international QA body, whether national, local, independent, or otherwise, will recommend independent QA for safer deliveries. It gives you that unbiased ground truth of what you are doing in your department. And equally, the goal of any system is to identify errors so that you can be aware of any issues you are having and you can account and correct for them. So let's move on to SunCheck. So SunCheck is our single radiotherapy QA platform. The goal of SunCheck is to bring everything into one platform. You have a single user interface, which is your web browser. It can be managed on cloud or on-premises IT architecture, and then it can be accessed from anywhere within your hospital network using that web browser as your interface, but you do not necessarily need an internet connection for that. The whole idea is that we can have everything in one place. So whether we are talking about patient QA or machine QA, we have that single user interface. So on the patient side, we try and cover the whole patient journey. So we have plan check, which talks about plan quality, plan compliance using our physics-based dose prediction. We want to talk about plan checks. We want to talk about DVH compliance. We want to talk about physics checks. Do your plan parameters match what your treatment protocol says? We want to do 3D secondary dose calculations and whether you want to use a collapsed cone or a Monte Carlo algorithm. We can offer both of those. For pre-treatment QA, this is when our hardware starts to help out. So we have direct device connectivity to our ArcCheck. You do not need a separate piece of software to run that device. You can use SunCheck. Alongside that, we can do absolute dose EPID dosimetry for pre-treatment QA. We can also bring in the log files from treatment delivery and reconstruct those and get a 3D dose distribution from that. Going one step beyond that, for pre-treatment QA, we can do in vivo monitoring. So that transit absolute dose EPID dosimetry then becomes in vivo dosimetry when we create a prediction of how the plan should look when delivered through the patient, and we take that measurement during the treatment delivery. We can also bring in the log files and we can reconstruct those on the cone beam CT so that you can look at a 3D dose distribution of exactly how your machine delivered the plan and how that looks on today's anatomy to help you make informed decisions about whether plans are safe, whether they need adapted, and whether they are optimal. On the machine side, on the same platform, we can cover things like your daily, your monthly, and your annual QA. We have more direct device connectivity to our daily QA3, our IC profiler, our PC electrometer, and our 1D scanner. They do not need an additional piece of software to run. You can run all of them through SunCheck. We can do automated imaging QA. So just about anything that you would deliver to your EPID or your KV system can be automatically retrieved and analyzed. We can help you manage your assets in your department, your different phantoms, your different QA devices. And we can recall the calibration factors automatically of your pharma chambers, electrometers to use during your QA. And equally, those routine tasks, whether it's tracking downtime, whether it's return to services, there's a huge amount of flexibility from the multiple international QA templates that are available, but also the customization that holds from that. And the automation that powers SunCheck is what makes this really powerful. And that is enabled through scripting and automated report generation, interacting with your record and verify system. So it really does kind of connect into your system. So looking in a little bit more detail on the patient side, we can do things like plan feasibility. So a physics-based dose prediction of exactly how this plan could look, what DVH is achievable or is not achievable before you optimize. And you can then review the plan that you've created and see how it matches that physics-based dose prediction. So you can compare what's achieved versus what is achievable. And the example that I show here shows that the primary kind of structure, which is the bladder here in yellow, the high doses have been optimized really well. However, the lower doses, there are significant room for improvements from where that prediction is, and that can help us ensure that the plans are indeed optimal. The complexity metrics then help us ensure that the plan is deliverable, and that integration with both scripting and reporting to the planning system and your oncology information system helps make it streamlined and automated. On the machine side, so that direct device connectivity I've already touched on really helps that software integration, reduces the amount of software that you need to have on different computers in your department. No locally installed software is needed. We can record those results, save them into our system automatically. There are many different protocols available within SunCheck. International QA standards are already preloaded, but you can customize those as and how you need to. Monte Carlo, it is the SciMocha. Monte Carlo, if anyone's familiar with that, is what we brought in SunCheck 5.1. It's worth noting that we are averaging around about 2 releases per year over the last 2-3 years now. So the pace of development is aggressive, and it's something that we are hoping to continue and improve further going forward, to help ensure that everything stays up to date with the challenges of modern radiotherapy. We launched another brand new module within SunCheck 5.1, and that was AdaptCheck. It takes a lot of those tools that I talked about earlier, plan checks, pre-treatment dose calculations, in vivo QA, etc., but it now can be applied on the Ethos machine. Ethos is an enclosed environment. So what we can do is we can replace the Mobius Adapt server with a SunCheck AdaptCheck server, and you can do all of your patient-specific QA automatically on that for both your adapted and your scheduled plans, and that data can now synchronize to your main SunCheck server so that you do not need to run 2 different environments. That data can synchronize to your main SunCheck server, and you would just have a calculation server on the Ethos machine if you wanted to run it that way. The flexibility in how SunCheck can work is one of the things that helps make it really useful, because every department, every country works differently. So it has to have that flexibility. But AdaptCheck for Ethos is something that we're really proud to be able to offer integrated into that brand new treatment delivery unit. Another treatment unit that we can now support is the Elekta Unity. So if anyone has one of these treatment devices, usually the planning system used is a Monte Carlo dose engine, but the QA is often very simple, a point dose, pencil beam. So we would always recommend that you QA your planning algorithm with an equivalent complexity algorithm for your secondary dose calculation. This helps make sure that you don't have false positives or failures in an online adaptive workflow, which are really challenging to deal with, and helps make sure that your agreement is going to be maximized because you have equivalent complexity in your dose calculation algorithms. So we have this new separate piece of software for the Unity that you can use and manage all of your secondary dose calculations for the Unity using a Monte Carlo equivalent algorithm. And we've talked about the ability to do that in vivo dosimetry, to take those absolute dose measurements with the EPID, compare that against a predicted absolute dose, to bring in the log files and reconstruct those on your cone beam CT. One of the challenges of modern radiotherapy is when a patient changes, when the anatomy evolves during treatment, how do we manage that? And something like SunCheck Patient can allow you to intelligently make decisions on whether a plan is appropriate for this patient or it is not. So it automatically runs in the background. Do not need to import or export any data. It is automatically retrieved, calculated, and the results are presented to you. So in terms of evidence behind this system, it's now approaching 10 years old. And, you know, one of our kind of power users in a really big center in Belgium has done over 300,000 fractions of in vivo dosimetry measurements. So I want to bring across the point that this is not new. This is not something that is beginning. This is an established, robust methodology that is being used comprehensively around the world. We have around about 2,000 hospitals using SunCheck globally, and this site in Belgium is certainly one of our favorites. They've done fantastic results looking at the number of failures from in vivo dosimetry and their causes. And over 5 years, they've managed to reduce the causes of failures. So they've become aware of things that they weren't aware of before, like the setup of their patients they were getting wrong with arms up or arms down, issues with immobilization not being consistent across their department, things like patients bladder filling, rectal filling, you know, managing that appropriately. You know, we hope everything is okay, but do we know? Something that's really important to kind of manage, and being able to reduce those positioning and anatomical changes and manage those appropriately. So really impressive to see someone using something so comprehensively for so many patients. If it wasn't automated, I don't think you'd be able to do this. But also then be able to take that information, act on it, and then be able to change their processes and see how their department becomes more safe as they go through using this solution. So one of my absolute favorite things to talk about is the work of Evie and the team from GZA in Belgium. Switching gears to the machine side of our platform. Again, same platform, same user interface. And the way a lot of departments work currently is, you know, they might have 6 different things to do daily with 6 different systems, maybe 8 processes, different devices, types of systems that they need to interact with to perform their monthly QA. They have lots of different spreadsheets, databases, different software for every single piece of hardware that they use. And it becomes impossible not only to manage all of this, but to train up new people, and equally to have a true oversight of the status of the QA in a department. Whereas with SunCheck, you will then just have one process to follow. Regardless of the number of devices that you use, you will have one QA template to complete. So this is an example from Moffitt Cancer Center over in the US. This was a 10 Linux center. They tend to have very big centers over in the US. But one of the things that I really do like is the the efficiency gains and how that they are given in percentages. So, they're talking 20%, 80%, and 70% efficiency gains from automating their QA, standardizing it, centralizing into a single system, and using SunCheck. That leads to a huge amount of hours that are saved. So the total efficiency gain for this center was 1,400 hours per year, which is just a phenomenal amount of time. If you think of all of the things that you have on your to-do list at the moment and think, okay, if I could have 1,400 hours a year freed up to be able to tackle that to-do list, I know that you could get a lot done. This is on the patient side. So this is Patricia from the University of New Mexico, again, over in the US, looking at both machine QA, but also some patient QA as well. And again, this was a 3 Linux center, but I just want to focus on those efficiency gains. Again, up to 66% improvements in efficiency that they saw in their QA. Huge number of hours that produces, and then allows you to do important things, improve your service, etc. So a really nice example from Patricia over in the University of New Mexico. So just in summary, to talk about SunCheck is to kind of just touch on that automated workflow, that scripting, that intelligence, that integration into your oncology management system and treatment planning system. Having that centralized data management, being that single quality management system, not just with individual QA tools, a fully comprehensive system. That allows benefits such as improving the efficiency, having time savings, helping you ensure compliance, whether that's regulatory or billing compliance. Really nice to be able to automatically produce those reports from a single system and be able to present them where needed. As you standardize things across your department, it just enables you to work more efficiently, train people up quicker, and then you can then take that extra time that is freed up to optimize your operations, improve the safety of your department, improve the quality of radiotherapy that you deliver, and work more efficiently, which then allows you to further improve each of those things as you go around that cycle. So that's the whole kind of message of SunCheck, is to take that single quality management system for all of these different benefits. I want to thank you all for your time today. And just before I go into questions, I just wanted to touch on the SunNuclear website and just say, you can learn so much more about our solutions through the website, the resources, the testimonials that are there. But also, if you want to get in touch with myself and my colleagues, then don't hesitate to do so. And the SunNuclear website is a great place to do that. So I want to thank you all for your attention. And if you have any questions, we'll be happy to go through them.
Thank you very much, Greg. It's a pity that I was not able to attend this webinar due to problems with my computer. I had to restart it 3 times. It is what it is. Another problem is that I don't see any questions in the questions. In fact, I see only one question in the Q&A section, although I remember when in the beginning there were more. So I remember that there was a question for Mercedes about ClearCalc, and the question was, one of our colleagues asks, how does ClearCalc work with log files for Electa Linux? Yeah. So can you please provide an answer?
Sure. So in that case, there is no problem. We just need to install a log file listener application, and we can work with Electa log files.
And there are questions for Greg Right now, I can see two questions. Again, apologies for probably this is some kind of weird problem with Zoom. I do remember that there were many questions, more questions than 2 or 3. Greg, can brachy treatment planning and QA be incorporated in your system? This is one of the
Absolutely. So from the really advanced systems like Electa Unity and Ethos right the way through Varian Electa, including the brachytherapy systems, the Accuray systems, CyberKnife, etc. We cover the full range of treatment delivery units.
And we have a question from a young colleague. He or she says, as a medical physics student, I want to practice programs within my field. Does Sun Nuclear provide any programs or free copies, he says, for students? Are there any opportunities for young colleagues?
Yeah, so what I would say is if you want to reach out to me directly, then we can discuss that and see how we can get you to get your hands on SunCheck and learn a little bit about it in more detail.
Or something similar? Hello?
Yep.
Can
Hello.
you hear us?
We can hear you.
Yeah, I can hear you. Greg, go ahead. I don't know. Have you?
Yes. Did you not hear the answer? Yes. So SunCheck is compatible with brachytherapy as well as all of the modern treatment delivery units.
Mercedes, there is a question about, I think for you, our colleague says for Radformation, AutoContour, is it only for Eclipse or it can be implemented for other TPS as well, TPSSs?
No, the reason why I show the Eclipse integration is because it's very visual to show how easy it is to launch it directly from there. But as you said, we also have AutoContour as a standalone application, so we could use that with any TPS just by doing some DICOM communications with the images and the RT structure sets as a regular application.
Greg, is there a log file analysis in SunCheck? And what kind of MLC QA checking by SunCheck? Any additional tools or fandom required?
Great question. So yes, alongside the log file 3D dose calculation, we do QA the log files. So doing things like root mean square, errors of individual MLCs, looking at the standard deviations, along with the dose rate, the MU, all those different kind of things. It does not require any phantoms, which I think was part of that as well. It just relies on the log files from the treatment delivery unit.
And another 2 questions for you also, Greg. One is how to minimize the angular dependence of detectors employed in patient-specific QA measurements. Magdalena is bombarding me with trying to solve. Okay, she has sent me all the list of questions. Thank you, Magdalena. Great. I don't think we have much time. We still have 4 or 5 minutes. So we'll try to cover as many questions as possible. Again, thank you, Magdalena. So Greg, yeah, how to minimize the angular dependence of detectors?
Great question. Great question. So the ArcCheck, which is our cylindrical device, always has the detectors perpendicular to the beam. So that helps reduce the angle, any angular dependence. Equally, because it measures the dose at 2 different planes, it allows you to measure the angle of incident directly. So if you do need to apply any angular corrections, you know that they are accurate. In the same way that the SRS map check actually has 2 layers of diodes. And for the same purpose, to allow you to accurately measure that angle of incidence so that any corrections that you do need to apply, you're applying them really, really accurately.
That's great. And does Sun Nuclear acquire log files from Electa machines? Does it capture running parameters like GAN current during the beam delivery?
Great question. So electors are interesting in that they produce a range of log files organically, but not necessarily incredibly useful to QA companies to calculate 3D doses. So what we tend to do is to monitor the treatment parameters of the LINAC live during a delivery, and we sample those every 50 milliseconds. It is primarily the ones that we would need in order to calculate a 3D dose distribution. So gun current might not be one of those that's primarily required in order to calculate a 3D dose distribution, but we would sample the delivery parameters, the MU, the collimation, the gantry, etc., and we would create what we would call a synthetic log file, a record of that delivery that we can then use for the 3D dose calculation, as well as the MLC QA.
And we have a very practical question for both of you, for both Sun Nuclear and Radformation. What are the licensing purchase options? Is it one-time license purchase or subscription-based? Let's start from Mercedes. Ladies first.
Yes, thank you, John. So in our case, Radformation has a subscription-based model because we don't want you to marry to us. So of course, if you're happy with us, we're happy as well that you continue with us. But we can also give you that option to not. So yes, it's a subscription, year subscription generally.
And for Sun Nuclear?
On the Sun side, it's flexible. If you want to go subscription based, you can do that. If you want to go capital purchase, you can do that. And equally, you can go all in and take the platform for your entire department. Or if you want subsections of functionality on individual machines, you can start off like that, and it is expandable so that you can grow as well.
Okay, we still have 1 or 2 minutes. So Mercedes, I think we'll close this discussion with you. First, what is the overall accuracy rate of your auto-contouring? Which organ has the least accuracy rate in multiple automated generation? I can imagine, but obviously you have some data perhaps, or some research studies behind this important question, the accuracy.
Yes,
of
absolutely.
auto-contouring is a very important question.
Absolutely. So we have these studies. Of course, I don't know the numbers off the top of my head, but of course, if you are interested in these studies, or for example, also linking with the previous question, if you're also interested in knowing more about the quotation, you can always write us at support@radformation.com, and we will be happy to send you all the studies that will be helpful to you. Also, kind of what Greg showed, you can also go into the radformation.com web. We have a lot of case studies and white papers, also white papers with AutoContour, for example, just stating all the accuracy, the precision of all the organs. So I think that might be interesting to say.
That's great. Thank you both for your great presentations. Again,